in this endpoint. So to take care basically of this, we need some other application that's going to scrape these metrics instead of us and going to collect them into the database. And that's going to be Prometheus. I forgot to tell one important thing, that we are using dimensional and hierarchical metrics. Hierarchical metrics are separated only by the name. So this is the old format that we were using before, and you can still find it in Axon Server and Axon Framework applications, but we left it there for the backwards compatibility. Here's the example. So you can see, for example, the metric name command seconds is referred to the command named my command, and it's referred inside the context that is named default. And in the dimensional metrics, there's a different format. You can see here's the name of metric, and the type is basically the name of the command, and the context here is the default. So this allows us more flexibility and allows us to create better dashboards with this, as you will see later. As I said, so we need a tool that's going to scrape our endpoint and collect metrics and save them into the database. And for this, we are using Prometheus. And the Prometheus is basically time series database optimized for basically time storing metrics. And it also provides us a pretty powerful language to query these metrics. So for example, here, this sum by status code, we can collect metrics and sum them by the status code. So we can do many other operations here, and this Prometheus query language is really, really powerful. And that's basically the core of everything what we are doing. Prometheus also comes with an alerting toolkit that we are going to see later. And also I need to mention there are differences between these time series databases. They are pull and push databases, and the Prometheus is the pull database. That means that Prometheus needs to be aware of your application that is exposing metrics. So for example, it needs to be aware of this actuator Prometheus endpoint. So it needs to know where is your application deployed, and it will basically scrape these metrics for interval that you set, for example, 15 or 30 seconds. And it will go to this endpoint and save these metrics to its database. There's also push examples where the application are pushing the metrics to the database and the database is not aware of the clients. Some other alternatives for the Prometheus, which are not open source, are InfluxDB, Dynatrace, or the popular Datadog. When you deploy the Prometheus, this is how the UI looks like. It's pretty basic, and you are probably never going to need it if you are using Grafana. But you can type some queries and you can execute them, get the results, or you can see some simple graphs in the Prometheus. But that's it. So, for example, if you need something more complex to visualize your data, you cannot do it with Prometheus. So Prometheus' main goal is just to save the metrics in the time manner and to enable you the query language to query these metrics. That's why we need Grafana, basically. Grafana is another tool that is open source, and it offers these UI plugins to visualize these metrics. So it's basically just a web application, just a UI application that connects to the Prometheus and provides charts, graphs, many alerts, many plugins like counters, gauges, heat maps. And Grafana only displays this metric, but in a really powerful way that it's super customizable, and you can create beautiful dashboards that really you can put there whatever you want, whatever is important to you. So in this example here, I can show you one really complex Grafana dashboard that there's even a US map with the heat maps with many different plugins. So this is how Grafana dashboards are going to look like. So to sum it up, how everything is connected here. Grafana needs to know where the Prometheus is, because, and this is this arrow here, because Grafana connects to the Prometheus and reads these metrics from Prometheus and just execute them in Grafana. So if you have a Grafana and Prometheus stack, you need to type Prometheus query inside of the Grafana, and that's going just to be forwarded to the Prometheus. It's going to return the JSON result, and that's going to be parsed and visualized by Grafana. Prometheus needs to know about Alert Manager, which is going to send alerts to whichever channel you want, like email, Slack, or PagerDuty, something else. And Prometheus needs to be aware of your application that are exposing metrics. So as we said, it's a pool base, so it needs to be aware of your applications. Here, this deployment diagram shows the GCE, Google Cloud Platform. And when services are deployed in the cloud, you probably don't know their address, IP address, and they're going to change. Everything is going to be done dynamically. So that's why Prometheus offers resolvers basically for services in the cloud like GCE, AWS, that's going to automatically find your services and connect to it. And I will show you this pretty soon. So I will now continue to the demo. Ivan will share the demo links with you. We created this repository, which basically contains everything that you need to know and everything to get started. So it's you need just 3 commands to start everything, and it will start the cluster with 3 Axon server nodes, 2 instances of the application. It will set up Grafana, Prometheus for you, and it's going to create dashboards basically. So, and there is a HTTP file that you can just run to create some commands and events, and you can just see how it looks like in the dashboard. So I'm going now to switch to this repo, how it looks like. So when you clone it, there is a README file which contains all the information that you need to know about provisioning, how to add the new dashboards, how to add new alerts, and so what are most important files that you need to know about. So, for example, in this alert manager contains the information about your channels where you want to forward alerts. Here is an example for the Slack. All you need to do is just to replace this API key with your own, and you're going to get notifications to your Slack channel when something is wrong. And for example, this alert roles that's in part of the Prometheus contains alerts when basically to send alert to the Slack channel. So for example, there is this instance down. So if there is some instance of the Axon server node which is down for more than 1 minute, you will get the notification. Or if there is a low disk space, if there is a less than 1 gigabyte of the space on the disk for 1 minute, then you will also get the notification. What is also important is this Prometheus YAML file. So this contains the scrape configuration, as I mentioned. So the Prometheus needs to know about your metrics. It needs to collect it. And here you can provide the property for the interval. How often do you want it to be collected? So we either put 15 or 30 seconds. So it depends. So if you want more frequently, it will going to have more fine-grained metrics, but it's going to have a large load on your system. Here we can see the jobs for the Axon server and for Axon framework. And there's this static configs. As I said, this is a Docker configuration, so we can just refer to the service. We know it's where it's going to be. But in the cloud, here you want to change this with something from GCE or AWS. So all you need to Google documentation, and Prometheus is offering this out of the box. So you can just say, I have GCE, I have it, my nodes in different zones. So they start with this name. So just find them and collect them automatically. What I already mentioned is the deployment diagram, how it looks like. And also what is really important to repeat, that Prometheus is the database, and it requires the persistent disk to store all of these metrics. Here you can also find instructions how to run this demo. All you need is just to do maven clean package to create the demo app image, Docker compose build to basically build all the configuration and Axon server images, and just Docker compose up, and it will start everything. So Prometheus service will be available on this port, and Grafana and 3000. And we are going to now switch to Grafana to show you how it looks like. So this is what you get when you start everything and start producing some commands and events. For example, here in status, you can see all the nodes that are active and you can see their status. So what I'm going to do, I'm just going to restart one node and that you can see how this status changes. But it's not going to be same moment because, as I said, there is a scrape interval, so it's going to be picked up in next 15 seconds or less. So Grafana, so you can see here, this is down, and it's going to take some time just to restart this node and see the status again. But so this Grafana dashboard, this is what you get out of the box, and there is almost no configuration to get it working on the Axon server. So there is only one configuration that you want if you want to enable gRPC metrics, which are something for the internal diagnostics, basically, that not all of the users need. So that's something that is optional. Everything else you get out of the box, and you're ready to start diagnosing the issues in your system. So on the left here, you can see the drop downs that you can just select metrics for a specific node, and you can choose a specific context or even more of them. And some red flags, basically why you want to have this dashboard and why you want to read it, is basically to prevent problems and prevent the production downtime. For example, this error warning shows how many errors and warnings are there in the log. So warnings are fine. So this happens if this node restarts and some other nodes reports that something is wrong, but it's going to go down after some time. And if this is the case, it's all right. But if they are consistent and increasing, that's probably a red flag, and you need to check the logs, what is happening. If you notice the errors, you should basically just see what is there. So this is why we connected errors to the alert, and this is in the demo that we deployed on the repo. So basically here also you can see the CPU usage for each node, and you can see available RAM, and this is really important. So you don't want to get out of the RAM, and because this is really going to create some side effects. The dashboard is split into the 4-5 different sections. First one is general, that just shows this overall system health. And there's a 2, 3, 4, 5 more. Another one is overview, which is just the current status of your commands, events, what are the numbers. But what else is really important in this general is disk usage. So you can see here for each disk that your Axon server is using, you're going to see available space there. And there is one more property here available, plus 24 hours. It's just a prediction how many disk space you will have tomorrow in this time, basically. So based on usage in previous 24 hours. So you can see, because I generated a lot of events today, it predicts that I'm going to have 200 megabytes less tomorrow. So this is something just to be used for the red flag. If you see this going down pretty much, then you probably need to expand your disk in time. So let me go back to the overview. You can see here the number of sent commands to Axon server since the startup of the Axon server. So if you restart the Axon server, this is going to reset. Same for the events and for the snapshots. You can also see number of currently processed commands and currently processed number of queries. And so these are all live stats instantly basically available to you. And what is important, the last token of the events and the snapshots in the base. So this is basically how many events you have in the event store and how many snapshots. So I will go to the next part. Now we have sections for commands, queries, events. And this is really important, this latency here. So you can see how long did it take for commands to execute. So this basically shows how long the command was in the registry of the Axon server. That means from the point it came to the Axon server, how long did it wait to get a response from the command handler. So this includes basically the command handler execution time plus the network latency that from the Axon server to the command handler and from the command handler to the Axon server. So this is the first red flag that you want to see, basically. If this is getting increasing, like 15 seconds or more, so there's a red flag, something is wrong. It could be that your command handler is really slow, that it's doing something that it shouldn't, or you have a problem with the network, or you're sending a lot of commands and the commands are stuck in the queue, in the registry, basically, for a long period of time, not being handled. This is also going to increase this latency. And that means that you need to scale up. So that you need more Axon framework applications to handle these commands. Also, what you can see here is throughput. The throughput is basically how many commands per second the Axon server processed. This can also be a red flag if you see that there is a low number and you can definitely handle more. So that is also a flag that you should probably scale up or increase or speed up your command handler execution. The routing of the commands is interesting, but we couldn't find a better way to visualize this. So the bottom part here is the source. So the source is the application that created the command, sent the command, and you can see here basically there were two applications sending the commands, this green one and the yellow one, and here there was only a yellow one. And you can see on the top target, the target is the application that is handling the command, so basically that is running the command handler, and you can see that there was two instances and it was handled by two instances. And that means the Axon server load balances between instances really well. So this is also could be a red flag if you have multiple instances and there are always only two colors, like here. That means that Axon server or your load balancer is not seeing your application, second application or third, and not load balancing commands correctly. Going to the queries is pretty much the same, so you can see the type of the query and the latency, so you can debug why this query is super slow. Same for the throughput, and the routing is same as for the commands. Subscription updates just shows how many updates there are, how many active updates are sent per each application. Events show how many events per second are being handled by Axon server, and you can see that sorted by context. And same for the snapshots. What is really important is this last token. The last token shows the token of the last event saved in the event store, and you can see that per context per each instance. And if you have these values here different, that means that some nodes are behind. So it's not saving the events in the event store, and that could be a big problem. So you can see some small gaps here. So this is fine because I restarted this instance and there was no metrics. So you can see this sudden drop down, but it comes back. But what you need to know is here. So you can see there's a slight mismatch. And this is because the Prometheus is scraping the instances in a different time. So if they would be scraped all in the same moment, they should have all tokens the same, but since it's not, it's fine to have this slight mismatch, but eventually they should always be the same here. So if they are not, this is an issue. So there is some nodes that are behind and that can create problems for you. So let me go to the gRPC metrics. I'm going to be short on this. So this is more advanced, more diagnostic. So just for the advanced users who want to know how the network behaves and what is happening basically under the hood, which gRPC messages are being sent between the nodes, and is there some network latency. So you can see that here. So this is the basically 5% first case, is 6 milliseconds. So this is pretty good. You can see basically also how many requests there are, which methods are most active, and what you can also see the response bandwidth, and you can also see which channels are taking most traffic. And sometimes it happens that there are large snapshots that somebody tries to save, and this creates some errors that the max size is exceeded. Then it's okay to take a look here and see what is happening. So basically, which method is responsible for that. Errors here just are errors reported from gRPC since start. So this is fine because the cluster was not configured. It couldn't see all the nodes for some time until everything got configured. What is interesting is these selections here. And there you can see if there are some elections happening at the moment. So sometimes you could configure cluster wrongly. You can have a lot of elections. For example, if some node is not visible, and this is the graph where you want to check if there are frequent elections. If everything is normal, it shouldn't be frequent. So it should be pretty much like this. Last, these are methods started and finished. This is just for diagnostics. So the bottom graph should be symmetrical to this above. That means that all the methods that start finishes in the short time. If the graph is not symmetrical, there is probably a big issue in the setup. So it means that there is probably a low memory, and the CPU is struggling to collect basically the objects from the memory, and just is too busy with garbage collecting, and other gRPC methods cannot be basically executed. So this is also what happened before, and this graph help us to diagnose this problem. So this would be the graph for Axon server. So let me create a summary. So this Axon server dashboard is available to you by default. You can download it from this link. It's on the Grafana market. You can just copy this and import it and play with it. If you want gRPC metrics, there are two flags properties that you want to set to true, and that's it basically. But the Axon server dashboard only provides the insight to what is happening inside of Axon server. So, for example, if your application is having problems with the commands, doesn't send the command, so a lot of commands are failing, and it's probably because something is bad in your application, and they never come to Axon server, then the Axon server will not be able to register these errors. So that's why we also provided the Axon framework dashboards that you set on your client, and there you can have even more insights, and there you can expand your metrics to include more data. So this is the point where I'm going to switch with Ivan, and Ivan will talk more about this and the business side of it. We will answer all the questions at the end or now during the chat. So, Ivan, would you take over?
Thank you, Stefan. Thank you very much. I will be sharing my screen, guys. You feel free to ask any question on the chat. For now, later on, we will open a discussion. Let me share my screen, and then we can start. Stefan, can you see my screen?
Yeah, you can continue.
Yes, that's great. So yes, this part of the webinar will be focusing more on Axon framework applications. Before we jump into the demo, which I have already prepared for you, I just want to briefly discuss what is Axon framework, what does it bring to you as a programming model, so you can enrich your application and implement event sourcing, or CQRS patterns that are quite in line with the DDD patterns as well. So before we dive into this demo, let's just briefly go to these components. So mainly components in Axon framework are messaging components. So it's a command bus, query bus, event processors, and event bus. All of these components are routing messages to, let's say, aggregates. Command bus will just route a command back to the aggregate, which will be able to handle this particular command. Similar thing with the query. Query bus will route the query back to the query handler, which will initially handle that query. Event processors are usually on the query side as well. They're just handling or reading or calling events from the event store and doing something smart with them. Usually they're normalizing them, putting them in some storage database that then can serve some web page, or maybe you can maybe forward them downstream. Really doesn't matter, but it's important to know that these components are usually messaging components, and you really want to know how fast these components are processing these messages, handling them. So what is the time needed in seconds to handle a particular type of message? This is something we will learn how to do and how to measure, how to monitor. Also, it's very important to know what is the current capacity of these buses. So for example, you would like to know, is this bus working at 100% capacity at the moment, or maybe lower? Maybe it's working like 50%, which is probably fine. You should be worried if you see that your capacity of any of these buses is close to 100% over the longer period of time. And that would be the case when you should be raising red flags, maybe yellow, but I would say red. Okay, let's go. Next slide. So this is to enable all of this. We provide you with a really nice module, a nice library, which is called Axon Micrometer. And if you would add that to your list of dependencies in your POM file, or maybe Granular build file, you would be fine. So it will just work out of the box. Additionally, you would also want to enable dimensionality with this property here, setting it to true. We're not able to do that by default, because in that case we would break compatibility with the older previous metrics that we provided within the Axon framework, which was heavily using drop wizard. At that time, it was strictly hierarchical metrics, right? So this is a dimensional metric, as Stefan already mentioned. And if you really want to squeeze value out of these dimensional metrics, my advice is enable this property in your application. So this will be placed in any Spring Boot application, which I will show later, within the application.property file or application.yaml file, depending on the format. A little bit about Axon framework metrics. So these are counters. This is the first type of metrics we abstract within Axon framework. We call it a message counting monitor, and it simply counts the number of ingested, processed, successful, failed, or ignored messages. So let's briefly just explain what is ingested. Ingested is everything. So whatever message you actually receive, we count that it's ingested. And when it's ingested, it can be processed or ignored. Really depends. Ignored, it can be ignored, for example, when you have multiple instances of your application and your event processor or event handler, let's say, is reading these messages in parallel with many different threads. It could be that one thread will read that event, but other threads, maybe from other application instances, will simply ignore it. So that's why we have ignored. Once processed, message can be processed, as you can see down below, successfully, or it can fail. And this is just an example how this specific metric looks like. This is the name of the metric, so command bus, success counter, total, so this is the name. And in the brackets, these are tags or dimensions. These are synonyms, so you will probably realize very soon that I will use tags and dimensions as synonyms. So it's obvious that this is just a total number of successfully handled commands within the application we call demo app. And at the moment, this is the payload type, right? So it handled a command of type issue command. And it handled like almost 3,000 of these commands. So this is the number that is telling us, okay, so I've successfully handled almost 3,000 commands.
Even you're not presenting anymore. You're not screen sharing anymore.
Okay, sorry about that. Is it good now?
Yes.
Yeah. Yes. I'm not sure. Was I audible? You were able to hear me?
Yeah, everything's fine.
So yeah, so ingested, processed, ignored, processed can be successful or failed. This is just an example. At the moment, we almost have like 3,000 of commands successfully handled. Timers. Timers are different type of metrics. We have also abstraction for these. We call it message timer monitor. It's a component in Axon framework, and it measures how long actually a specific handler will take to handle specific message. So let's presume that, for example, event processor in this case is handling events, obviously. And these events belong to this application we call demo app. Payload type or type of this event is issued event, and processor that was actually handling this event is named like this. So this is just a package name. By default, Axon framework will take a package name of your event handlers. If you don't specify it otherwise, which you can do with the processing group annotation you can place on top of your event handlers. But in this case, it's showing us that for this particular message, it took 0.74 seconds. So it's not 1 second in total to handle this specific type of event. So please observe that here payload type and processor name are now tags or dimensions, and which is very convenient. Usually before, like in the past, when we were using hierarchical metrics, this was not possible. I mean, this was different. This processor name was actually the part of the metrics name. So it was located here at this place. And that's not convenient. In that case, you could not really create a general dashboard like the one I'm going to show you later. You always have to create a specific metrics. And this is actually why we had to explicitly now enable this dimensional parameter in the property file. Otherwise, you will be breaking maybe all dashboards that you have or something like that. We didn't want to do that. So just, enable property and you should be fine. So timers, they measure time needed to handle or process particular type of command. Because of dimensions, we can even measure which event handler actually is problematic one. The one that is actually taking too long to handle particular type of messages, which is really interesting. It can guide you to the places where you maybe have to fix your design a bit as well. This can be also explained on the command side. So if you see that maybe your commands are not handled very, very fast, maybe your aggregate command handler method is calling some remote service or something like that, which takes time, introduces latency, and you should be fixing that. We will show that later as well. Capacity, it's a gauge. Actually, it measures capacity. So in this case, it measures, for example, how many percentage of your command bus is occupied at the moment. So let's presume that if your capacity at the moment is 100%, and this is happening over a longer period of time, you should be really worried. This number here is showing the number of threads. We will work to fix this because it's not clear. This should be a percentage and it should be like 20 or 30 percentage as a number here, rather than the number of threads. I will explain later how can you tolerate that. We were not able to prepare this for the demo, but we will work to improve our Grafana dashboard, so in the future this is more clear. Oh, am I on the demo? Yeah. So it's a demo time. I will now switch to first source code, and then I will show you some nice Grafana. I already created the application and I'm already running this locally. These are true Grafanas, two dashboards that you can actually download from the Grafana marketplace. They are totally publicly available for you. It's just a JSON, so you can then include or insert this JSON into your own Grafana. All right, let's. Before we go to the source code itself in my IntelliJ, I want to show you again that actually Axon visibility demo is also publicly available, hosted on Axonic within our Axonic GitHub organization. This is a nice README file explaining how can you run it. It shouldn't be that hard. It's Docker driven. We didn't want to introduce Kubernetes because it can introduce some sort of complexity. This should be running on all local machines, I guess, easily. Axon server dashboard available here. The first Axon framework Grafana dashboard is available here. This one is a very general one. It will work either on hierarchical metrics or dimensional metrics. Really doesn't matter which of these two you choose. This should be working on both of these versions. This is the latest dashboard. We call it a micrometer. And it's actually, it will work only if you enable this property and you use dimensions or tags. Otherwise, it doesn't make sense to use this one if you are using hierarchical metrics. So I have my setup running, and my setup includes one application which we scale to 2 instances. We call it a demo application. It's connected to Axon Server Enterprise cluster, which contains 3 nodes at the moment, with the first node being a leader. And this is a dashboard, the first dashboard I'm going to show you. But before we do that, let me just go to the source code briefly and explain a little bit more the structure of the application itself. So the application itself is located here, and it's a Spring Boot application driven by Maven. So that's why we have a POM. The POM file is having actually this Axon micrometer dependency. Maybe I can just enlarge this for a bit. And this is the module you should be included. This is mandatory. At the moment, we are at version 4.5, so stay tuned. This will grow. We are heavily working on this. For all of this to work, you would need to include Spring Boot Starter Actuator, which will give you this /actuator/metrics endpoint, which actually Prometheus then will use to scrape all of the metrics. Also, you need a micrometer core, and you have to choose one of the registries that is going to collect this metric and store it durably somewhere. Prometheus is very nice. It can be easily configured, and this is the way how can you do that. Once you have this dependency, immediately you will see also /actuator/Prometheus endpoint available on your application, which is a Prometheus handy format, so Prometheus can use that out of the box. So that's all regarding the POM. Rest of the POM is mainly Spring Boot dependencies. Let me quickly show you the application properties. So this was the property I was talking about before. Please set that to true. You need to enable and expose Prometheus and metrics endpoints. Otherwise, it will not work. Of course, in production, you should be considering security and securing these endpoints, most probably. So pay attention on that if you are really going in production with this. And I guess that's most of the application. Application is very simple. It's a gift card application, so we can just create some gift cards. This is a setup related to the Docker. So this is the place where all Docker files are located for all of the tools that you're going to use in the setup. These resources is very interesting, especially for Grafana. This is also the place where you can see how can we auto provision all of these nice dashboards that we are about to show you totally automatically, and it will just happen by running this Docker compose file with the command docker up. So, for example, the first thing you should be doing to run all of this is, of course, you have to build your application. You usually do that with this command. If you do it, please turn off some Docker daemon. So I have that running already in my machine, because this maven clean verify will also run a creation of a Docker image. This is configured within the POM itself. So in the POM file, there is a Docker Git plugin. Here it is, and it's responsible for building this, building the Docker image out of the source code. It will build a multi-layered image by using distroless base image, which is very convenient. Doesn't have any shell, so be aware of that. If you really want to SSH there, you would be able to do that. So this is for a good reason, because shells are kind of dangerous. If you have them in your Docker images, they're usually security hosts. So when you run this maven clean verify, it will create an image out of this application. It will and it will be available. Then you can just simply run the Docker compose file, which I already did, and it's already running. I didn't want to waste your time running it right now, but if you would like to do that on your own, you just navigate to this folder, source main Docker, and run Docker compose up. Before that, you can run build and then up. And after a couple of seconds, you will be able to see this, sorry, there it is. Yeah. This picture showing you that we have this application connected to the cluster and everything is working, right? So dashboard or Grafana dashboard, Grafana is running on the port 3000, and this is how it looks like at the moment. So I'm using the first Grafana dashboard I mentioned before. This is a general framework, Axon framework Grafana dashboard. I will show you first that. Last 3 hours. Okay. Oops. Oops.
Did you select the right instance or application?
Oh, let me check. Oh, this is Axon server. Demo. Let's select both of them. So yes, so this is very important part. So here you can select which application you want to observe or monitor. It's very convenient because now you can use only this one dashboard and then select any application you have in your system landscape. And it will work the same for any Spring Boot Axon framework application you have there. Of course, this application can be scaled horizontally to many more instances, and here you can pick all of them, just select some of them or maybe one of them. For example, if you just select this one, you will see only the metrics for this particular one. If you select both of them, we are going to aggregate these metrics for you, and these graphs will be updated immediately. So let's take some 3 hours time period. I think it's more interesting because I ran some tests, right? So also important to mention, I think Stefan did a great job here. Mostly you can use these samples to create some commands or events or queries. I hit these endpoints a couple of times. You can do the same. You can even increase this number to 2,000 or 20,000 and make some fun out of it. See how your metrics is going up and down. As I said, have fun. So I did that, I think, a couple of hours ago. I was preparing for this. And here you can now see these are the counters. So the first metric you can see here is just, we are counting things. How many successful, failed, processed, ingested, and ignored commands we have in the system. Let me show you this one. So if you go here and click edit, it's very simple. We just use these metrics. So this is the name of the metrics that we are using from the application that is exposed on the application level, right? So here we're just reading. So we have to just create a query for it. So that's the thing we are doing. We are using sum to aggregate by all applications and by all instances. And that's why you can here change and go from one to another. It will just simply work. But yeah, this was easy. Maybe these counts don't mean much to you. So that's why usually with the counters, you would like to do some ratings. And this is something we did in this second diagram. So here we apply some irate function. It can show you the frequency of your input. For example, it can show you what is the load of commands, in your system, and at what time particularly you have this load. It's the great one, where it's getting lower. You will probably see something that is usually like a batch, right? It's going up and down. So it's very convenient to track these things. But you can play with this even more. So please use this as a lead-in, as something that is a good starting point for you. You can add your own graphs on top of this dashboard very easily. These two are very important. So these two are mainly technical metrics, but with these two you can measure latency and capacity, and it can tell you how busy or how much time actually, let's say, your command bus or command handlers are taking to handle particular type of commands. Let me show you this one as well, and then I will switch to another dashboard. So you see here, I'm using timer. So that's why I showed you earlier timer as a second type of metrics. So besides counters, we have timers. So here we are measuring how much time command bus is taking to handle all types of messages, right? So, and this is the query. So we do average on this in this case. So if you go across two different instances, we will use average. And here it's saying that maybe I can actually just focus on this one. Here is saying that at this particular time, almost 2:10, it took almost 0.4 seconds to handle all commands. And this was happening for a while, right? For this moment in time. Then it got down. So at this point, it took 0.138. Right? So it's a very low number. It's not even a second. This is great, right? If you see that this number is going up, right? So these are seconds here on the epsilon axis. It's going up to, let's say, 5 seconds. You should be worried. Especially, you should be worried if it's on 5 seconds for a long period of time, and this line is very flat, right, for this period of time. Then you should be worried. This really means that your commands are queuing somewhere, and your handlers are really slow. Sometimes this is indicating that your design is maybe not good. Usually, this is the case because we sometimes tend to call some third-party services from our command handlers, which we probably shouldn't be doing. But yes, timers, we call this latency, very important. Capacity, also technical metrics, always kind of isomorphic to the timers and latency. But here we are now measuring, you know, how much of capacity is taken at this moment in time. So this is telling me that at the moment I'm using 0.1 number of threads to handle these messages, right? So this is very low number, but what it really means, right? So let me show you that as well. So if I go back to my IntelliJ and I go back to my application properties, this is a property that is actually setting or configuring the number of threads that you can configure to be available for any command handler, right? So by default, you have 10 of them. Similar for the query, right? So you have 10 of them. That really means in parallel, you can maybe handle, let's say, 10 commands or 10 queries, right? You should be having 10 cores as well. So I can really say you can do that in parallel, but nevertheless, this is the place where you configure the maximum number of threads that are available for command handling or for query handling, right? So having in account that you have 10, that really means that 10 now represents 100%. So if I go back to this dashboard and I look at this capacity again, if this would be 1 here, you know, this is a 1 thread, but let's assume this is just 10% of the capacity, right? So you have to do this calculation on your own, right? So taking into account that this epsilon axis is representing the number of threads, and you know that the 10 you have in total, so 10 is a maximum, that really means 100%, and you do the math, right? So what we plan to do is to actually render percentages here. In order to do that, we first need to expose this configuration property as metrics as well, and then here we can just label it as percentage and we do the math for you. But just for information, I just wanted to explain a little bit better what it is, because it is a little bit confused. Nevertheless, you know, latency and capacity, please pay attention. Similarly, or symmetrically, you have the same thing for the queries, right? So queries are the output, so you can measure the rate with the counters, you can measure the latency with the timers, and you can measure capacity with the queries, right? With the event bus, it's here. It's similar, right? So you want to know also how your event bus is performing. This is the place where actually events will get stored to event store, and similarly to command, you want to be able to measure them. Let me just show you that how these metrics really look like. So always hit edit to see what particular metric we are using. That is always available on any Axon framework application. This is a good place to start learning. We specifically use all timer seconds, but you can really specify either success timer or you know, or fail timer or any other more specific timer you really want, and enrich this dashboard with more details. So just for the demo reason, I think all timer is probably good enough. So similar thing, right? So it's also a timer. But that's not all. So we are not using much of the dimensions here. So what we don't know when we see an issue here, for example, let's say we see 10 seconds here latency on the command bus. We don't know which particular command handler in our aggregate was actually introducing this issue in the first place. So we are not able to narrow down the problem because we don't know which concrete command handler was causing this issue. In order to do that, we created another dashboard, which is specifically which can be used only with the dimensional metrics. And as you can see here, you have a lot more legends. You have a lot more data now. Let's focus on command bus latency and see what's going on here. What's the difference, right? So as you can see here, we can do average only by the application, but also we can slice it by the payload type. And this is exactly what we are doing here. And then in this label over there down below, you'll use this payload type as a variable and configure this accordingly. So it's placed here as a name. So now you can select any particular, you can slice it now by any particular, for example, I can say this one, all right? Or I can just focus maybe on this one, or add command. Maybe I'm more interested in the timers for the payload type of add command. Then it will only show me this particular graph. So now you can really narrow down and you can really inspect a particular command handler that is maybe causing the issue. Same for the capacity, actually same for everything. Additionally, now you can really easily generalize this dashboard for any event processors that you have in your system. Event processors are always very specific. It's something that you provide name to. So whenever you create your application, you create your own event handlers and you use this processing group annotation to give this event processor a name, right? And when you give it a name, obviously it would be nice that this name is also a tag or a dimension. And if it's a dimension, then we can slice it by it, like we are doing here, exactly here. Right? So now I can see how my add event processor group or maybe some other processing group is handling these events. At what speed, you know, how much time it takes to handle particular type of event. So also payload type, very important. You have that as a dimension as well, out of the box. Now you can know which particular event you have issues with handling. So this is wonderful. I mean, you can now really have a deep insight into your event processors with only one graph, which is located here and representing latency by measuring time. So this is the time actually once the message is ingested till the message is processed. Any message, command, query, or event. We can measure this latency. Most of these latencies or timers, we can use them on the Axon server as well. There, on Axon server side, I also include networking. So here, networking is not included, so we just measure how actually your application is handling these messages from the point it got ingested. Okay. So that's also the difference between these two dashboards. Yeah, if you really want to play with this, one thing you can do, you can always go here and let's say, you know, let's for example play with this. Let's remove this and let's examine what this metric really is. Okay, let's play just command capacity. Okay. So this is now something different. Let's find out what it is. Let's remove our legend, which very specific. It's placed here. You see. Now when we do that, now you get the description of this metrics, and now you can do you can learn from here. You don't have to switch to another script, right? So you can here spend some time understanding this. You can see here how many tags you have available. So you can slice by this. And now you can start writing some query using some function to sum it or to aggregate it. But this is usually a nice place to start. Yes, Stefan. Sorry.
Maybe you can zoom in a little bit just for participants to see which tags there are. Yeah, that's much better. So.
Yeah. Yes, so I just dumbly put the name of the metrics I'm interested to explore deeply, and I can just experiment, put it here. I will remove the legend, so out of the box, Grafana will just present everything it knows about it directly from the Prometheus, and it's very convenient because now you can see here how many tags you have available, and now you can start slicing, right? So for example, and applying some aggregation function like sum in this case. So if you want to measure and want to sum this command capacity by instance and by application, you can do it like that. You can dissect it by the payload type as well, or maybe you don't want to. So maybe you can just use the application, right? So in that case, you will get only something like this. Right? But here you can use, let's say we go back, take this one. Okay, so here you see that we are slicing by these two properties now, which is much better. And now you have to give it some name. So you can use this as variables. So for example, I can use only payload tab. Oh, sorry. And now it's showing only this. You can really play with that. Usually, if you use by here, you most probably would like to have both of these here, but it really depends on you. Something like that. So feel free to play with it. You know, don't be afraid. I think it's a good way to learn it. Okay. What else I can show you? We still have just a little bit of time. Let me show you what you can actually do much more with it. So metrics really is a powerful tool. So by only counting, and you realize that we can count things here, right? So we can even count how much particular command types we have in our system, right? Can you imagine that these are booking? And our hotel booking business would be very happy if we can forecast how many bookings we will have in 1 month or 2 months from now, right? So you can do that by only collecting metrics. You can really do that now because we are able to do that very granularly, even on the command or event type, which is very powerful. So it has some business perspective on that, right? So I think it can be used very smartly to do some prognosis or forecasting for the business sake. So it's very interesting. But you can, for example, reconfigure all of this out of the box and include more tasks, more dimensions, right? It's very common that your messages are also including a user or maybe a role. So you want to know who is sending a command, or you maybe want to know who created this file, this event. If you have this data in your messages, then this would be the way to reconfigure all of these metrics I was just showing you by also adding the payload tab as we add by default. So this is something we add by default. But if you're overriding this behavior, it's a good idea to actually always add a payload. You don't have to, but usually it's a good idea, right? But besides the payload type, you can include, like I'm doing here, all the metadata I have in this message, I'm including it in the metrics as well. They will become tags. And that really means that if you go back to the dashboard here, you will not only see the payload tab, you will see user equals something, you will see role equals something, and that would enable you to make a really interesting queries here and do some more powerful forecasting as well. Now you have what, you have when, of course, and now you will have who as well. So that's why it's very convenient on the metric level. So on the metric level. Okay. I haven't configured that. We don't have much time, but the code is available publicly online. You should be enabling or uncommenting this section, making this a configuration, Spring configuration, and it will just load these beans. By loading the beans, it will just reconfigure metrics for the event store, event processor, command bus, and the query bus. I'm doing the same thing here, just listening to my metadata and enriching, adding more and more tags on my metrics. API is very convenient. We will not change this API. It's a very stable API. It's dimensional. You only need to provide these functions. Usually, reading from the message is convenient, but you can do something else as well, depending on your need. We have a couple of dispatchers, dispatch interceptors that actually will run as well, mocking some user and just, enriching our messages with this user ID metadata so we can test and demo this. I can imagine that this user ID can come from a Spring session or something like that, and then simply you can change this dispatch interceptor so it can propagate authority back to the domain layer, where you can maybe do authorization as well. So it's dispatcher here is convenient for other purposes as well, but here we are using it for just mocking the user so we can display it on the metric side, on the metrics level. Yes. So that would be all. I guess feel free to download and clone this repo. I think Stefan, please correct me if I'm wrong. This will run Axon Server Enterprise Edition with the 3 nodes.
Yeah.
License is included.
We provided a demo license, so it's going to be available until mid-May, so you can play with it. So use this opportunity for that.
Yes. So this should work. The license will expire in 2 weeks from now, right?
Yeah.
Okay.
15 May.
So the Docker image is available. We built the Docker image of Axon Enterprise on the fly because Axon Enterprise jar file is located within this project, so you are able to try it. So please do, provide us some feedback. Let us know what you think. Open an issue on a GitHub. Discuss it with us. Thank you.
Thank you, Ivan. It was really, really useful. And we have a few questions, so if somebody else also have a question, now it's time to write it because we are soon going to finish. One of the questions was, can we see the command handlers? So basically see errors. Is the command cancelled by server or some other issue? For that, you can what Ivan showed, basically, you can just create an interceptor, a message interceptor, and catch all the errors. So in this catch, you only need to create basically a counter. And in the counter, for the dimension, you can put the name of the exception that happened and increment every time that this exception happens. And then you will be able to create a panel that will show each command, why it's failed, basically the whole statistics. And here you can even split it by the Axon server or some runtime exception. So you are pretty free to do whatever you want here. Ivan, there is one also question for you. Maybe you want to read it and answer from Prashant. The last one. So event latency considers event propagation or event ingestion to the event handler, or is just event ingestion to the event processing? He didn't get this part.
Event propagation to event ingestion to the event handler. Event latency considers event propagation to event ingestion to the event handler. No, so this, let me go back on the slides maybe. No, it's not on the slide, sorry. It's more on the
demo.
No, it's doesn't want to switch anymore. Why? I cannot open my Chrome anymore for some reason. Yeah, so event latency, the thing I showed you within the application, it's event processor. It's from the moment you ingest the message, right? So it's the moment when your application is aware that actually message is there, to the moment that the message itself is processed, right? So it's that time that we measure. So it's essentially the time needed for your application to handle this particular message. It doesn't include the traffic. This is something we can measure on Axon server side, probably better, like including also the networking. But on the application side, it just from the moment it got ingested till the point it got processed, either successfully or with error. It really doesn't matter. It can be processed either in these two ways, but it will be, this is the time that got measured, which is also a very important time. I mean, usually these are the bottlenecks. Usually this is the place you can actually configure your application, so it's a little bit faster. Also, it's a good sign because we haven't talked about alerting, but this is the point where you have to think about alerting. If you see that it takes a long time, like a couple of seconds or 5, for example, you should be thinking of vertically scaling your application, increasing number of threads that actually can handle this. Or if you hit the wall with a vertical scaling, you can start scaling it horizontally as well.
And there is one more question. How do we measure latency in that case? We had this from one of our customer.
Yeah, well, it's a latency just for this particular window, right? From the moment it got ingested to here. But there is another metric as well, which is actually called event latency. We haven't used that on a dashboard. It was still experimental, but it can give you a little bit more insight into the latency itself, like the real sense latency, right? So I think I know what you're thinking here, but for this probably you need to use event latency monitor name we have provided. We don't have it on the dashboard, unfortunately. Maybe you can contact us, Prashant, on the Slack channel. Maybe we can provide you with this as well. But now I don't have a demo for that.
Also, what they can do is to create some fine-grained metrics for the latency. They can create the interceptor and wrap their own timer around basically the message handler if they want to do that. Thank you. So I think there is no more questions. So to sum it up, yeah, we created this demo project, contains everything that you need to get started. The webinar is recorded and we are going to provide a link as soon as the recording is ready. Given that, we would finish for today. I hope this was beneficial for all of you, and I hope it was fun also. Thank you everybody for coming.
Thank you guys. Have a good day.